Hey guys, so today we're going to do a unique part of factoring with what is called a difference of squares. Difference of squares is a unique type of polynomial, and you'll notice it because it has a square in one term, subtraction, and the square in the second term, and they kind of all look the same. They're actually pretty easy to factor if you follow the same procedure all the time, but I'm going to look at different examples because they can get a little bit more complicated in terms of numbers and terms that are or what that actual terms look like. So we'll do a couple different examples, see how it works, and then there's lots of practice for you guys. So I'm going to show you how it works with a couple of examples. The first one is super easy. So x squared minus 36. Now, we know this is a difference of squares because one, it's got a subtraction in it. So they always have a subtraction in it, and it's usually two terms, where the first term is a square and the second term is a square. So x squared broken apart is x times x, and 36 broken apart is 6 times 6. So that's how you know it's a difference of squares. Both of the values are squares with a subtraction. Here's what you're going to do with it. This is going to become x plus 6 and x minus 6. Now let me show you why it works out this way. If you wanted to check it, when you go to do it, this one, when we multiply, we get x squared plus 6x minus 6x minus 36. And you'll notice these two terms, the plus 6x and the minus 6x, are going to cancel out because they just equal 0. And you get back x squared minus 36. So that's where it comes from. That's why it's called the difference of squares. And that's why this particular way to factor it works. You just put a plus for one of them and a minus for the other. Let's look at another example so I can show you again how it works. So we'll look at B, which is 49m squared minus 25n squared. So what I do is I break it down. This is 7m, and this one, if we square root it, is 5n. So it becomes 7m plus 5n times 7m minus 5n. So they're exactly the same. The only thing that changes is that sign that's in the middle. Let's look at C. C has a little bit of an extra step in it. If you notice, this is a3, so a cubed, and this one just has an a. So the one thing that's common in both of them is that they have this a. So I always say, let's common factor first. And I said that in yesterday's lesson. But it still applies to these ones. If you can common factor it first, let's common factor. So let's pull that a out. And what we have left is a squared minus 16. And now this is just a difference of squares. So easily keep that a there because it's not going to disappear. But then we can just go about our business. A plus 4. Root 16 is 4. And a minus 4. Easy peasy, guys. Okay, D. Now, yes, it has a 4 on it because it's y4 minus 1. But what I do know is this can be broken into y squared. So it is still a difference of squares, even though it doesn't at first seem like it is squared. So what you're going to do is break it into y squared plus 1 and y squared minus 1. Now, this one actually has another step because if you'll notice, this one here is actually also a difference of squares. So let's actually factor this further. You cannot do anything with that first one because it has a plus in it. But we can factor this one into y plus 1 and y minus 1. There are examples like this one in the practice, so I'm just pointing it out that if you factor it and then you notice you still have another difference of squares, factor it further if you can. Last question, E, which was w minus x squared. I'm just going to write it, and y plus z squared. Yep. This one, you're going to treat each of these like this is a squared and this is a squared. So kind of keep it together. And so what happens is you're going to get w minus x plus y plus z. And that's one of the terms. And the other term is w minus x minus y plus z. Now you can leave it like that, or you can attempt to get rid of all those brackets just to make it nicer, which is probably what I'm going to do. So this one becomes w minus x plus y plus z. And this one, that minus sign applies to both of them in there, so it's w minus x minus y minus z. And you can write it out like that if you need to. The point is to kind of make it look much more simpler than it is. And this is the best simplified expression you can get for that one. So be careful when you do these. Be mindful of what could potentially be a squared, just like we did in this D example that it had a 4. Be mindful that there are examples where it might be easier to common factor first, and then you'll easily see the difference of squares. But that's really it for today. I gave you guys lots of practice, and the quiz has a bunch of different examples on it. So enjoy. Should be a nice, easy day today. And I look forward to marking your quizzes. Bye, guys.